again continuing the class on the topic chemical thermodynamics. Today we will discuss on internal energy. Internal energy of the system. Internal energy of the system means system contains some amount of substances. It may be in various states, it may be in gases or liquid or solid state. So the energy contained by the atoms and molecules of the substance that is contained in the system, with the sum total of energies contained in the substances contained in the system is called internal energy. More precisely, we can interpret the internal energy is as per the definition that your definition is it is the sum total of translational kinetic energy, uh, rotational kinetic energy, vibrational kinetic energy, nuclear kinetic energy, electronic energy, molecular interaction energy associated with the atoms and molecules of the system. So, the system contains some atoms or molecules. In case of gaseous system, uh, gaseous substance contained in the system, the atoms or molecules, they have the motion. That means in straight line motion. They can travel in a straight line before two collisions. And in the total system, the molecules have some translational motion. That is why they have some velocity and they contain some translational kinetic energy. Rotational kinetic energy means atoms and molecules, they're rotating about its own axis during the motion, so they have some rotational kinetic energy. Vibrational energy means in case of solid system, the atoms or molecules, they are located at a particular point inside the bulk of the material, and they travel to and fro. That is called vibrational. That is one type of periodic motion. And similarly, the nuclear energy, that means in the nucleus, the nucleons, that means protons, neutrons, they are compacted within a small volume that called nucleus. So with some binding energy. So these energies called nuclear energy. Similarly, electronic energy. The electrons are revolving around the nucleus in several paths called energy levels with certain velocity. So they have some uh, kinetic energy, maybe translational or positional, that is potential energy. And molecular interaction energy means there is a force of attraction between molecule and molecule. So some amount of energy is contained by the molecules due to this. This is called molecular interaction energy associated with the atoms and molecule of the system. So here in mathematical is taken a term for internal energy, that is capital E. E is equal to ET, means kinetic energy, translational kinetic energy, then rotational kinetic energy, then vibrational kinetic energy, then nuclear energy, then electronic energy, and molecular interaction energy. So the sum total of energies contained by the atoms and molecules of a substance that is contained in the system, that is called internal energy. The absolute value of the internal energy cannot be determined. So each term, each component of the energies cannot be determined. So that is why the total amount contained in the substance, that the absolute value cannot be determined. So as we are not able to find the absolute value of the internal energy, we may be able to find the change in internal energy. If we give in the initial and final value, what is the change? The change can be ascertained or determined. The internal energy of the system is a state function. So here it is change in internal energy that is denoted by delta E, that is EF minus EI. EF means internal energy at final state, and EI means internal energy at initial state. So the difference is your change in electrical energy, change in internal energy. So the internal energy is given that internal energy is a state function. That means this is a function. This is a quantity which depends upon the change in internal energy depend upon the final and initial state of the system. This is because it depends upon the initial and final state of the system, and not on how it attains the state. That means doesn't depend upon the path followed during the process. Hence, the change in the internal energy depends on only the initial and final state of the system on uh, the intermediate states. So this is the change in internal energy. Then another thing, what are the different characteristics of internal energy? So the internal energy, is extensive property. You know what is the extensive property? Because the property whose the value depends upon the amount of substance or mass of the substance contained in the system. So that is called extensive property. So internal energy, if the mass will be more and more, then the internal energy will be more and more. So then next thing is, or it is a thermodynamic state function. We already discussed, because it depends upon the initial and final state of the system and nothing other factors. Whether it is it is not a path function, it is a state function. It is independent of the path followed. It does not depend upon the path. In which path it is, the system. Suppose this is a state point and this is a state point, and from to bring from this point to this point, you can go to this point different paths, in different paths. So this doesn't depend upon the path. This depends upon the initial internal energy in initial state and internal energy in final state. So this is the factor. So the internal energy has complete differential. Means you can write differential of E, that is integral E1 to E2, lower limit E1 and E2, upper limit E2 can be written as E2 minus E1. So this can be your change in internal energy can be found out in this expression. So that is why we say that internal energy has complete differential. The absolute value of the internal energy cannot be determined. We have also discussed this. Cannot be determined. The amount of internal energy depends upon the nature of constituents and mode of burning. So the amount of internal energy depends upon the nature of constituents, how what type of material contained in the system, and what is the bonding, intermolecular bonding exists between them. Though this may be fixed, this depends upon the factor. Another separate factor, the amount of internal energy also given in the system is different under certain terms, given set of conditions. So the internal energy is fixed. If the terms and set of term conditions is fixed, then the internal energy is certain value, having certain value. If the set of terms and conditions, so pressure, volume, temperature, these are the conditions. So if it is varied, then in the different ways, it is, if it is calculated in different ways, the internal energy will be different. So then we come to the change of internal energy is the difference between the final internal energy and initial energy can be written as delta E is equal to E2 minus E1. Delta E is equal to E2 minus E1. So the sign change of sign or sign convention for internal energy. If E2 is greater than E1, if the final internal energy is greater than E1, then the uh, internal energy taken to be positive. If E2 is less than E1, that means final internal energy less than the initial internal energy, the internal energy is taken to be negative. And the unit, that means the units used for internal energy is for in SI system, that is your joule, and in CGS system, that is erg. So the internal unit of internal energy is this. You can calculate the change in internal energy in joules or erg. So what do you mean by the significance of internal energy? What is the significance? What is the significance? Significance is there is importance, physical importance of this internal energy. It is equal to the exchange of heat energy between the system and the surrounding at a constant temperature and constant volume. So this thing will go through in detail when we'll continue in next class, that is laws of thermodynamics. So for today, this much. Next, we'll see in the next class. Thank you.